Welcome. So when a system gets compromised, it doesn't just stay quiet. It actually keeps a diary of everything that happens, and today we're going to learn how to read it.
All right, let's start with the big problem every digital forensics investigator runs into. An attacker gets in, does what they came to do, and then tries to just vanish. They'll try to delete their command history, right? You know, the stuff in .bash history. They might even remove some files. But here's the thing. The system itself is always recording what's going on. They almost always leave footprints. The real question is, where do we look for them?
Yeah, the answer is right there in the digital breadcrumbs, these log files. They're basically a chronological record of everything that happens on the system. For an investigator, this stuff is pure gold. These files tell a story, and our job is to piece that story together.
Okay, so every investigation has to start somewhere, right? You need to secure the crime scene. And in the world of Linux forensics, that crime scene is almost always one specific, really crucial directory. Our whole investigation, it's going to kick off in /var/log. Now, you might remember the file system hierarchy standard. It's kind of the rule book for where everything goes in Linux. Well, it designates /var/log as the place for, well, all the logs. And remember, /var is for variable data, files that are always growing and changing. And log files? Perfect example. Just think of it as the system's central records room. It's got everything from system messages to login records to errors. This directory is the very first place a digital detective looks for clues.
All right, let's dive in. First things first in any investigation. How did the bad guy get in? We've got to find the digital equivalent of a busted lock or a smashed window. What was that initial point of entry?
And for that, we're going to turn to our first key piece of evidence, the authentication logs. Now, quick heads up, the file name can be a little different depending on the system. If you're on a Debian-based system like Ubuntu, you're looking for auth.log. But on a Red Hat system, say CentOS or Fedora, it's going to be called secure. Same job, different names. Think of this file as the system's bouncer. It writes down every single login attempt, whether it was successful or not. It's absolutely essential for spotting unauthorized access.
And look at this. This is the exact moment they got in. This is a real log entry. This is what it looks like. You can see a process here called SSHD. That's the secure shell daemon, the service that's always listening for SSH connections. And look what it says, accepted password for DevOps. It even tells us where the connection came from, this IP address right here. Bam! That is our smoking gun for the initial breach.
So let's just break that down for a second. It's amazing how much info you get from just one single line. You've got the when, the exact timestamp, you've got the where, the host name of the machine that got hit, you've got the who or what, in this case the SSHD process that handled the login, and of course, the most important part, the how, a successful password login over SSH from a specific IP address. All right there.
Now look, in any investigation, one piece of evidence is good, but you know what's way better? Multiple pieces of evidence that all point to the same thing. One log entry is great, but to build a really solid case, we need to cross-reference it. This is how we go from, I think this happened, to, I know this happened.
So to back this up, we can check two other really important files, WTMP and BTMP. So WTMP, that records all the successful logins. So we should totally see an entry in there confirming our attacker's session started right at that time. Now BTMP, that's the opposite. It records all the failed login attempts. So if we check that file, we might see if the attacker was just banging on the door trying to guess passwords before they finally got in. A classic brute force attack.
All right, so the attacker is in. But what did they do next? Getting in, that's just step one. The real goal for pretty much any attacker is to get full control. And that means they need to escalate their privileges.
And you know where we find the evidence of this little power grab? Right back in the same auth.log or secure file. Because that file also tracks sudo usage. And as you know, the sudo command is what lets a regular user run stuff as the super user, as root. So by tracking this, we can follow the attacker's journey to becoming the all-powerful admin of this machine.
And hey, don't just take my word for it. Experts in the field will tell you these sudo logs are absolutely critical. They don't just tell you that someone escalated their privileges. No, they can show you the exact commands they ran. It's like finding the attacker's playbook.
So an attacker isn't going to go through all this trouble just to get kicked out on the next reboot. They need to make sure they can get back in whenever they want. We call this establishing persistence. So the question is, how did they set up their secret backdoor?
Well, a really common way to do this is to hijack the system's task scheduler, which we know as cron. Cron jobs are just scheduled tasks that run automatically.
You know, things like system backups, running updates, that sort of thing. Attackers just love them because they can sneak in their own malicious script and set it to run every so often, which basically guarantees they'll always have a way back in.
So where do we look? Well, we can check the actual configuration files in /var spool/cron tabs to see if any new shady-looking tasks have been added. But for the proof of what actually ran, we've got to go back to the logs. Some systems have a special cron log, which is handy, but a lot of the time this stuff just gets written to the general system logs. And again, this depends on the distro. On a Debian system, check syslog. On a Red Hat box, it's probably messages.
Okay, we've gathered clues from all over the place. Authentication logs, login records, system logs. We've got the entry point, the power grab, and the persistence. Now, it's time to put all the puzzle pieces together and see the full story.
And here it is. This lays out the entire attack chain perfectly. At 1449, boom, the intruder gets in with SSH. We see that in auth.log, and we confirm it with WTMP. Just a couple minutes later, at 1452, they use sudo to become root, also right there in auth.log. And then finally, at 1458, they set up their backdoor using a cron job, and that event gets logged in syslog. Every single step.
So, you see the crucial point here, right? It's all about how these different logs work together. No single log file is going to give us the whole picture, but when you start correlating the events across auth.log, WTMP, and syslog, that's when you can build a complete, undeniable story of what the attacker did, from the moment they got in to the moment they set up shop.
And that's really the magic of log forensics. You're taking what looks like just a bunch of random lines of text from different files, and you're weaving them together into a narrative. When you do it right, you turn all that messy, raw data into a crystal clear story of what happened, when it happened, and how.
So, we've pieced together the attack. We know the whole sequence of events, but our job's not done yet. We know what happened, but the next big question is, how do we find the malicious tools and scripts the attacker actually left behind on the file system? Well, we're going to dig into that in our next explainer.